In this video, we're going to learn about the nomenclature of alkenes and alkynes. This is part of our learning objective for learning about the IUPAC systematic names for alkenes, alkynes, alkanes, and their cyclic counterparts, as well as when they have substituents on them. So the nomenclature rules for alkenes and alkynes build upon the nomenclature rules we learned for alkanes, meaning we are still trying to find the longest carbon chain in our molecule. The only new requirement is that longest carbon chain must contain the double or triple bond in the molecule. So it's a requirement. When you number your chain, you have to use the suffix "-ine" if it has a double bond, or "-ine" if it has a triple bond. This is to indicate whether it contains a double bond or a triple bond, just like the words alkene, alkyne, and alkane. When you start your numbering, you want to minimize the number of the double or the triple bond. Not minimize the numbering of the substituent. You want to minimize the number of the double or triple bond whenever possible. The double or triple bond will exist between two carbon atoms, but you want to give it the lower of the two numbers. You need to specify where that double bond is located, because that double bond could be located between carbons 1 and 2, between carbons 2 and 3, and so forth. There's options, so you have to specify. Then you have to give the location of all the other substituents based on that. So in this molecule, I have 1, 2, 3, 4 carbons in the longest chain. So that's going to give me the parent of bute. There is a double bond, and so that's going to be butene. Then I have to give the numbering of where that double bond starts. That double bond starts at carbon number 1 and then goes on to carbon number 2. So I give it the lower of those two numbers, which is a 1. So it's a 1-butene so far. Now all those carbon atoms are accounted for, and now I have to give the location of this methyl group. That methyl group is off of the third carbon, and so that means it is 3-methyl 1-butene. This is an example of showing you that the multiple bond must be included in the longest chain. This molecule, if I numbered it in this way, it could have a longest chain where there are 7 carbon atoms present. But then how would I name that as a substituent? I can't. There's no way of naming that as a substituent, because then it end up in the prefix and it'd be all weird. So we can't do that. Instead, let's ignore that, and we'll number it where we can include this double bond as part of our chain. 1, 2, 3, 4, 5, 6. And so it is a hexene. The ene indicates that there is a double bond. I started numbering from this direction because the double bond looked closer to that end. Now I can see that my double bond is between carbons number 2 and 3. 2 is the lower of those two numbers, so I give it a 2-hexene. Then I have to name this as a substituent on that chain. That's on the third carbon, so it's going to have a number 3. And there's 1, 2, 3 carbons in that, and so that's 3-propyl 2-hexene. Now I want you to pause the video and try to name this compound. Unpause the video when you are ready to continue. Okay, so this is a double bond, which means it's going to have an ene in the name. And so that is chloroethene. You might be thinking, why aren't there any numbers here? Why isn't it 1-chloro, 1-ethene? The reason why there's no numbering in this name is because if we put the chlorine on the other carbon, it would look like this. And then that carbon would have to have 2 hydrogens. Now watch. If I spin this top molecule around 180 degrees around this point, it's going to look exactly like that. That means that these two things are the same molecule. There's only 2 carbons here, and so the only possible location for that double bond is right here in between those 2 carbons. There are no other possibilities. So, no isomers, no numbers. So if there's no isomers present, you don't have to worry about numbering in the name. Here's another practice problem for you. What is the IUPAC name for this molecule? Go ahead and pause the video and try to work this out on your own. Unpause the video when you are ready to continue. Okay, so when we name this molecule, first of all, we have to find all of the carbons. There's 1, 2, 3, 4, 5, 6, 7. So 7 gets a root of hept. That is a triple bond, and so it's heptyne. It's drawn linear because it is 180-degree bond angle here. And so it is drawn linear, and so you just have to recognize that each dot should be about equal spacing apart. Now for numbering. If I number from this end of the chain, then that triple bond would be at number 4. If I number from this way, then it would be a 3. So that's going to be 3 heptyne. I got to pick the lower of the 2 numbers. Now I've accounted for all of these carbons. Now I have to find out where this bromo is. This bromo is on the 6th carbon. So that's 6 bromo, 3 heptyne. Here's some special considerations. If the multiple bond is equal distance from both ends, you can begin numbering at the end that's closest to the first branch. So for instance, if I numbered this direction, this double bond would have a number 3. And if I number from this direction, it's also going to be a number 3. So if I number from this direction, I can minimize the number of that and minimize the number of that at the same time. Out there in the wild, there's these common names that exist. They're called common names because they're used in the general public, but they are frowned upon by the chemistry community, and the use of them is being discouraged. And so I'm not going to even bother teaching you how to decipher it or anything like that, because I'm hoping that eventually, if people stop learning it, then it might die off. IUPAC naming is so much better, and you will get to appreciate how much better IUPAC is through doing your Mastering Chemistry homework. This common name, you can see they just add in extra syllables like everywhere. So IUPAC is calling this ethene, propene, 2-methylpropene, and in common nomenclature, that's like ethylene, propylene. So you might have heard of like propylene glycol. So these names exist, but like you're not going to be asked common names on the test. That's just something you'll have to deal with on homework. So, nomenclature of cycloalkenes. When naming cycloalkenes, you want to number so that the double bond is between carbons 1 and carbon 2. The 1 is usually omitted in the name. It's implied because it's always going to be between carbons 1 and 2, so you kind of know where it is by default. But since you do get to pick which of these two carbons is carbon number 1, you have to keep in mind the location of the substituent. So if you numbered this direction around the ring, and you numbered it that way, then that substituent would be on the 5th carbon. If you number around the ring in that direction, then it's on a number 4. And so that is making that a lower substituent number, which is preferred. And so this molecule would be named, that's 4-methyl cyclohexene. Now let's practice naming these compounds. Go ahead and pause the video and try to work out the numbering and stuff for these molecules. Unpause the video when you're ready to check your work. Okay, so here we do have a cyclopentene, that's a hexagon, cyclohexene. My choices for numbering are either to make that a 1 and that a 2, or that would give this methyl group a carbon number 2, or I could number it where that's a number 1 and that's number 2. And that's preferred because that's going to lower the substituent number of that methyl. And so that's going to be 1-methyl. I'm going to make that an actual 1. All right, and now I'm going to number around. So that's 1-methyl, 2, 3, 4, 5, 6. This is a propyl. So it's a 6-propyl. And M comes first in the alphabet. So the methyl is going to need to come first. So that's going to be 1-methyl, 6-propyl cyclohexene. Now for our next molecule. This is a ball and stick model. So let's first translate that into like a line structure or something a little bit easier to look at. That's 1, 2, and then a double bond. Then it goes zigzaggy down 1. Then 1, 2 more carbons. And then there is a methyl off of that, and a methyl off of that. You could also do a condensed structural formula if you like. Okay, so here I get the choice of numbering from this direction or numbering from that direction, but I have to minimize the numbering of the double bond, and it looks like it's closer to this direction. So it's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that is a hexene, and it's at carbon number 2 is where the double bond is located. Now, where are my substituents? I have a substituent there, and they're both methyls. So that is a dimethyl on carbon 2 and carbon 4. So that's 2, 4 dimethyl 2-hexene.